Hi, welcome to Sachun Study Tech. Today topic is finding the maximum and minimum element. Find the maximum and minimum element in an array using the divide and conquer strategy. So here the time complexity in straightforward method, the time complexity is big of n, auxiliary space is big of 1, no extra space is needed. Here the straightforward method. Here the recursive call, here the time complexity is big of n, auxiliary space is big of log n. Now we can discuss about the algorithm for the straightforward method. Algorithm. How to solve this, how to find out minimum and maximum element in that array in straightforward method. So here the maximum and min, max min, and A is the array and n is the size of the array. Maximum, min. In straightforward method, minimum equal to a of 0 and maximum equal to a of 0. So for example, here the number of elements, this is 2 and 8 and 5 and 3 and 1. So here the array index, it is a array A, index is 0, 1, 2, 3 and 4. So min equal to a of 0, that is 2, and max equal to a of 0, that is also a 2. So here min equal to 2 and max equal to 2. Now for I equal to 1, that is the second element you can compare with from second element onwards, because the first element is assigned to min and max. So that's why I equal to 1 and I less than n, I plus plus. So here if a of I less than min, then min equal to a of I, then min equal to a of I. If a of I greater than max, then max equal to a of I. This is the straightforward method. You can find out the minimum and maximum element in that array. Now you can see here min equal to 2 and max equal to 2. Now a of I, that is a of 1. A of 1 value is 8. So 8 less than minimum. What is the minimum value? 2. So here it is, if the condition is fail, so you cannot update the minimum. Then here here you can iterate to. So the next element is a of 2, and also you can compare with this and second element, which is the minimum. And here also second element and third, the first element and third element you can compare with. So which is the minimum. So you can compare with this element and last element, which is the 1 is the minimum. Ultimately you can find out the minimum element. Like that here also you can find out the maximum element in this straightforward method. How many number of comparison is needed? That is 2n minus 2 number of comparisons is needed for straightforward method. Okay, now you can apply the divide and conquer strategy. You can find out the minimum and maximum by using recursive call. So what is the algorithm here? Algorithm, maximum and minimum that is lower bound, upper bound, max and min. So in this case here, for example, the array consisting of only one element. For example, here only one element is there. This is the array A, array name is A. So only one element is there. So it is a small problem. You cannot divide it into sub problems. Directly can say that. So minimum and maximum equal to that element, only one element. That is, if how can find out that if lower bound is equal to upper bound, that means here lower bound is 0, and upper bound index is also a 0. So lower bound is equal to upper bound, that means in that array consisting of only one element. Then min equals to A of lower bound, and also max equal to A of lower bound. It is a small problem. Okay, you cannot apply the divide and conquer strategy. Directly can say that you can solve that problem directly. For example, else if lower bound is equal to upper bound minus 1. So what is the meaning of this? That array consisting of two elements. Now you can see, for example, first element is 2 and next element is 5. Here the lower bound index, first element you can indicate that here it is 1, it is a upper bound. So array A. So that is equal to L, lower bound is equal to upper bound minus 1. That means in that array consisting of two elements. So lower bound is 0, upper bound minus 1. So upper bound value is 1, 1 minus 1, that is also 0. So that means that array consisting of two elements. Now you can find out if A of lower bound less than A of upper bound. Two elements is there, just you can compare, only one comparison. Here A of lower bound less than A of upper bound. If the condition is true, so the minimum value is A of lower bound, and maximum value is A of upper bound. Else, if the condition is failed, then else block is executed. So the minimum is A of upper bound and maximum equal to A of lower bound. So here it can see the two elements is there, just only one comparison, A of lower bound less than A of upper bound. For example, here the A of lower bound value is 2 and A of upper bound value is 5. 2 less than 5. The condition is true, then min equal to A of lower bound, that is equal to 2, and max equal to A of upper bound, that is value is 5. So minimum value is 2 and maximum value is 5. If the condition is fail, for example, I am taking the first element is 5 and second element is 2. Now the minimum equal to A of upper bound, so that is 2, and max equal to A of lower bound, that is 5. Okay, that array consisting of two elements. For example, that array consisting of more than two elements, then else you can find out the mid element. Now we can apply the divide and conquer strategy. That array consisting of more than two elements, then lower bound plus upper bound by 2 can find out the mid element. Again you can call the recursive function max min Here the lower bound, and up to mid it is upper bound, and maximum and minimum. So again the second part also you can call max and min. Here the lower bound is mid plus 1, upper bound is upper bound, and maximum 1 and minimum 1. Now again here it can return the maximum and minimum, here also can return the maximum and minimum. Just you can compare. Here it is maximum less than max 1. You can update the maximum equal to maximum 1, and also if minimum greater than minimum 1, so you can update the minimum. Min value is min 1. So this is the algorithm. Now we can see the example. For example, the array consisting of more than 2 elements. Now we can see it is the 2 and 8. Here the 5 and 4 and 1. So here array consisting of more than 2 elements. Then here this else block is executed. You have to find out the mid value. So here it is index 0 and 1 and 2, 3 and 4. Have to find out the mid value. That is lower bound is 0 plus upper bound is 4. 0 plus 4 that by 2, that is 2. The mid value is 2. Now mid value is 2. So this entire array is divided into 2 parts. Here you can see lower bound to mid. That is lower bound to mid value is, the index is 2. So this part consisting of 3 elements, 2 and 8 and 5. This part consisting of 2 elements, that is mid plus 1, that is the lower bound and upper bound. So mid plus 1, the mid value is 2, 2 plus 1 that is 3. So here it is one part, 4 comma 1. This is the second array. So here also we have the more than 2 elements. Here also you can divide it into 2 parts, that is 2 and 8. Here also only one element is there. So here it is a small problem. We have the 2 elements is there. It is a small problem. You cannot divide it into subparts. Directly you can say that just you can compare these 2 elements. You can find out the minimum value, that is 2. What is the maximum value? Maximum value is 8. So here we have only one element. So that is the minimum and maximum. So minimum equal to 5 and max equal to 5. Now you can compare with this min and this min. So here you can see max less than maximum 1. So maximum is updated, and minimum greater than minimum 1, min equal to min 1. You can update at that minimum value. So here the min 2. So here it is min is 5. So minimum value is 2 for this array, and maximum value is, here it is 8. Here the maximum value is 5. So you can compare with 8 and 5. So maximum value is 8. So here you can see what is the minimum and maximum. Here also small problem, you cannot divide it into subparts. So that is min equal to 1 and max equal to 4. Now you can compare this min and this min. So here minimum is 2, here minimum is 1. So the minimum value is 1, and here the maximum value is 8. Here the maximum value is 4. So that is maximum value is 8. So in this array the minimum value is 1 and maximum element is 8. Now you can see the recurrence relation of the min max. So here if the only one element is there, zero comparison is needed. That means that what are the element is there, that element is a minimum and maximum. We have the two elements, one comparison is needed, we can compare with one comparison, so we can find out the minimum and maximum. If the array consisting of more than two elements, then that entire array is divided into two parts and two comparison is needed. So here it is, we can write T of 1 that is equal to n by 2 plus Tn by 2, that is 2Tn by 2 plus 2. So we can solve this recurrence relation. You can use a substituted method here. It is 2 is there, T of n by 2, here can call the same function here, it is 2. So in place of n, you can apply the n by 2. So here it is 2t in place of n by 2. So here in place of n by 2 by 2, that is n by 2 into 2, that is 4, plus here it is 2. Simplify this, 4t n by 4 plus 2 into 2, that is 4 plus 2. So here it is 4. Again you can apply the same thing. Here it is 4 plus 2. In place of n, you can substitute n by 4, that is 2t. In place of n by 4, that is n by 4. Here it is into 2, that is n by 8 plus 2. You can simplify this, 4 into 2, 8t n by 8 plus 4 into 2, that is equal to 8 plus 4 plus 2. So you can write this 2 cube t n by 2 cube plus 2 cube plus 2 square plus 2 power 1. So here you can apply the k times, that is 2 power k t n by 2 power k. Here it is 2 power k plus 2 power k minus 1. For example, k value is 3, here the 3 minus 1, that is 2, like that. Here it is a k minus 2 plus and so on, 2 power 2 plus 2 power 1. So here the problem is, small problem means, if the array consisting of only one element, zero number of comparison is needed. For example, that array consisting of two elements, then only one comparison is needed. So here you can apply the same thing. The problem is, in certain time the problem is small, that means only two elements is there. That's why n by 2 power k is, let n by 2 power k, that is equal to 2. Okay, so t of 2, only two elements is there, t of 2, that is equal to only one comparison. For example, for n equal to 2, so only one comparison is needed. So that's why let n by 2 power k equal to 2. So that is equal to n by 2 equal to 2 power k. So here the 2 power k, in place of 2 power k, you can use the n by 2 here, n by 2 t of, here n by 2 power k value is 2, t of 2 plus, here you can see summation of I equal to 1 to k. You can write this, summation of I equal to 1 to k, 2 power I, that I value is 1, 2 power 1, I value is 2, 2 power 2, like that up to k. So it is in geometric progression. So what is the formula here? A into r power n minus 1 by r minus 1. So what is the value of A? That is the starting element, that is 2. 2 into r means 2, 2 power n means k here, 2 power k minus 1 by r minus 1, that is 2, 2 minus 1. So here you can see 2 power 1, 2, 2 power 2, that is 2 into 2. So that value, r value is 2. Now plus here t of t value is, t of 2 value is 1. So here it is value is 1 and n by 2 into n, t of 2 value is 1 plus 2 into 2 power k minus 1 by 2 minus 1. Now 2 power k value is n by 2. So can write plus here it is 2, here 2 power k value is n by 2 minus 1 by 2 minus 1, that is 1. So here it is n by 2. Now we can see n by 2 plus 2 n by 2 minus 1. So that is equal to n by 2 plus 2 into n by 2, that is n minus 2. Now n plus 2 into n, that is 3n, n plus 2n, that is 3n by 2 minus 2. So in recursive call here you can find out the minimum and maximum. So these are the number of comparison is required, 3n by 2 minus 2 number of comparisons. In straightforward method you can require 2n minus 2 number of comparisons in straightforward method. So this is the recurrence relation. Thank you for watching this video.